Hello everyone. Welcome to Academic Coordinates. Before us, we have got a hyperbolic function. F of x is equals to 2 divided by x plus 3 plus 1. So we're requested to initially find the asymptotes, right? So the asymptotes are the lines, or you can call them the imaginary lines that the graph approaches, but it doesn't necessarily touch them, right? So looking at this equation right here, we have got x is equals to -3 as the first asymptote, and then we have got also y is equals to 1 as the second asymptote. And if I can just put it to you guys that x is equals to 3, this is the vertical asymptote, right? And then y is equals to 1 is the horizontal asymptote, right? Okay, then secondly, we are requested to find the intercept, right? Firstly, to find the y-intercept, the y-intercept is actually where the function or where the graph will actually cut the y-axis, right? Let me just draw here. Okay, this is the x-axis, this is the y-axis, right? The equation of the y-axis is x is equals to 0, right? And the equation of the x-axis right here is y is equals to 0. You know what I'm saying? Okay, cool. So basically the y-intercept is actually where this graph will actually cut the y-axis, right? So at the y-axis, x is equals to 0. Hence, our y-intercept is going to be f of 0 equals to 2 divided by 0 plus 3 plus 1. So f of 0 equals to 2 divided by 3 plus, okay, 1. I can also write it as 3 divided by 3. So that equals to 5 over 3. So the coordinates of the y-intercept is 0 and 5 over 3, right? Okay, now for the x-intercept, okay, so basically this is where the function is going to cut the x-axis, right? And we need to note that at the x-axis, y equals to 0, right? So in our case, f of x will equals to 0. So here we let f of x equals to 0. So that will be 2 divided by x plus 3 plus 1 equals to 0, right? So we can just subtract 1 on both sides. So we're going to be left with 2 divided by x plus 3 is equals to -1. And then we continue right there. Okay, so it's going to be, we're going to multiply by x plus 3. So it's going to be 2 is equals to -1 into x plus 3. Then we continue. This is going to be 2 is equals to -x minus 3 right here. So from here, we can see that our x is equals to -5, right? X is equals to -5. So the coordinates of the x-intercept is -5 and 0, right? Okay, cool. Then now the next question requests us to sketch, we are requested to sketch f of x, right? So first and foremost, the intercept is -5 and 0, so it's going to be somewhere here. Say -5, it's not drawn to scale. -5 and 0, and then the y-intercept is 0 and 5 over 3, right? So 0 is somewhere here, then 5 over 3 is somewhere here, 5 over 3. Okay, and then the asymptote is x is equals to -3. So we can say maybe it's here, -3. So it's a vertical asymptote. the graph will approach this line, but it will not touch it. Okay, and then the horizontal asymptote is y is equals to 1. All right, so it's just here. It's just here. So we've got 1 here. Trust that's visible. Okay, cool. And so we can now sketch our function, Okay, so before we can sketch our function, I want us to take note of something. The value of a, this value is positive. So the function will be in this quadrant and in this quadrant, right? So our hyperbola looks like this. And this side it's gonna pass -5 right there. So this is our hyperbola, right? Then, so this is question number 3. Then number 4 now, they tell us something. They say f was reflected along the x-axis, right? So just to take note here, f of x, if it is reflected along the x-axis, then this means that it's going to be negative f of x. You know what I'm saying? Okay, so in this case, negative f of x is named as h. So h of x equals to negative f of x, right? So this is f of x reflected along the x-axis, right? So basically it's going to be negative 2 divided by x plus 3. Also this negative is going to affect 1 here, so it's going to be -1, right? And so h of x is negative 2 divided by x plus 3 minus 1. Okay, so for this function we are requested to find the axis of symmetry with a positive gradient, right? So let me just lift up my paper right here. Okay, cool. So basically looking at this function h of x and f of x, what has changed is that the vertical asymptote has not changed. It is still x is equals to -3, but the horizontal asymptote now have changed. Let me just see if I can get another color here. Okay, so the horizontal asymptote has changed to y is equals to -1. So it's going to be somewhere here, right? Trust you guys can see that. So these are our 2 asymptotes now. And another thing is that okay, so let's see if we can find the intercept. Okay, we don't actually need to find the intercepts of this graph. We just need to know where they actually intersect right here. So the 2 asymptotes intersect at x is -3 and then y is -1, right? The initial asymptote intersected at x is equals to -3 and y is equals to 1, right? But now these ones intersect here, and these are the coordinates of that point right there. Okay, so basically guys, to find the axis of symmetry, we know that their gradient is equals to 1, or it might equals to -1, right? So this is the one we're interested in. So we've got y is equals to x plus c, right? And then now we're going to substitute this value into this equation. So it's going to be, okay, y is -1 is equals to x is -3 plus c. So this means that c is equals to 2. Hence, the axis of symmetry with a positive gradient, its equation is x is equals to x plus 2. Thank you guys for watching. Enjoy the rest of your day.